the parabola. So it has to be in standard form before we can talk about that. So look right beside you and look at what the standard form looks like. The squared term is isolated by itself on, in this case, the left side. It really doesn't matter which side it's on, just so that the squared term is by itself. Is 1a in standard form? No, because the squared term is not by itself. So how can we fix that problem? How about we multiply by the -2? Because it also doesn't have the constant in front of it. The not squared term is the one with the constant in front of it. So here's our equation, -2y equals x squared. It wants the focal width. The focal width is the absolute value of 4 times p. So the number in front of the y is 4 times p. So the focal width here is the absolute value of -2. So the focal width is +2. Now the question doesn't ask us this, but what is the focal length? The focal width is the absolute value of 4p. The focal length is just p, so divide by 4. So the focal width is the focal length is 1/2. Okay, but the key is it's got to be in standard form, so the squared term has to be by itself. All right, B. Write the equation in standard form. Now, when I look at that, I automatically know that it's a parabola. How do I automatically know it's a parabola? Because y is the only squared term. All of our other conic sections had both x squared and y squared. Okay, all the other ones had both x squared and y squared. This only has one squared term, so that I know that it is a parabola. So if I'm going to write this in standard form, looking at my standard forms of my parabolas, the squared term was by itself on one side, everything else was on the other side. So let's do that. Let's keep the y squared where it is and the 2y. The other stuff has to go to the other side, so that becomes positive 6x minus 13. Okay. To put it in standard form, guess what we have to do? Complete the square. We have to complete the square. So divide 2 by 2, we get 1. Square it, we get 1. So we add that to the left side of the equation. But we got to keep the equation balanced. So we also have to add it to the right side of the equation. So on the left side, we have y plus 1 squared. That's good. Starting to look like our standard form. On the right side, we have 6x minus 12. That's not exactly how it looks in standard form. In standard form, they factor out the constant in front of the x term. So this would be y plus 1 squared is equal to 6 times x minus 2. That is the equation of this parabola in standard form. Okay, let's do another one. 3x squared minus 6x minus 6y plus 10. It's another parabola because we only have x squared. Both x and y are not squared. So let's keep the x's where they're at. Move the y's to the other side and the constant. So we've got positive 6y minus 10 on the right side. Now, if we have to complete the square and there's a number in front of the quadratic term, we must start by factoring that out. Of just the left side. Okay, we're not doing anything to the right side right now. Okay, let's complete the square. -2 divided by 2 is -1. -1 squared is +1. but we don't add positive 1 to the other side. Anybody remember when there's that GCF in front? We have to multiply by that GCF in front. Okay, so we add 3 to both sides. So 3 times x minus 1 squared is equal to 6y minus 7. Okay, our standard form didn't have a number in front of the squared stuff, so we need to divide everything by 3. So we've got x minus 1 squared is equal to 2y minus 7 over 3. And then our last step is to factor out that GCF on the right side. Okay, if we factor out a 2, it's like we divide by 2 or multiply by 1/2. So that's going to leave us with 7 over 6 inside of our parentheses. Okay, let's look at a couple more, all mixed up. So we've got to figure out which conic section it represents. Okay, so for example A, which conic section can we automatically eliminate? A parabola, because we've got x squared and y squared. So it's definitely not a parabola. It's one of the other 3, and I really can't tell right at this moment which one it is, but I know it's one of the 3. So guess what we have to do? We have to complete the square twice. So to save myself a little bit of space, while I'm pairing my x values together, I'm also going to go ahead and factor out that 9, because I know I have to do it eventually. So I've got 9 times x squared minus 2x. I'm going to do the same thing with my y. So I'm going to go ahead and factor out the 4. I got y squared plus 2y. And that constant, that negative 23, goes to the other side. All right. Complete the square twice. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I add positive 1 in that first set of parentheses. I add 9 to the other side of the equation because I have to multiply by that GCF. Complete the square for the second one. I'm also going to add 1. 2 divided by 2 is 1. 1 squared is 1. And so then that means I add 4 to the other side. All right. So we have 9 times x minus 1 squared plus 4 times y plus 1 squared is equal to 23 plus 9 is 32 plus, or not, 36. Yeah, 36. All right, so does that look like any of our standard forms of our equations yet? Does it look like a circle? Does the equation for a circle have any constants in front of the parentheses? No. So I don't think it's a circle. Is it a hyperbola? No, why not? Because, well, we haven't put it over a squared or b squared yet, but the main thing for a hyperbola is, what did I mention? Is the minus. Okay, it's the minus. There's no minus between our parentheses there. Okay, so it's got to be an ellipse, but let's see how we actually turn it into an ellipse. Its ellipses are equal to 1. So we go through and divide by that number right there. So 9 over 36 reduces to 4, so this is x minus 1 squared over 4. 4 over 36 reduces to 1 over 9, so this is y plus 1 squared over 9 is equal to 1. So it is an ellipse. Tell me some things about the ellipse. Where is its center? The center is at 1, -1. Okay, is it oriented horizontally or is it oriented vertically? Okay, X does come first, but what did I add to your notes there? What's the relationship between A and B? A is greater than B. So which one, is it horizontal or vertical? Vertical, because the Y is over the bigger number. Okay, the Y is over the bigger number. So it's vertically oriented. So that means its focal axis is X equals the X value of your center. So that's X equals 1. And if it's vertical, then it is taller than it is wide. Okay. I really don't anticipate them asking you questions about the vertices, but if you can draw that much, you should be able to figure out, or at least be able to eliminate some answer choices to figure out what the vertices are. All right, let's do another one. Let's do B. Okay, let's do B. X squared minus y squared minus 2x plus 4y minus 6 equals 0. Does anybody have a hypothesis as to which conic section this one's going to be? Okay, let's find out, because nobody sounded very confident about that. So let's see here. We got x squared minus 2x minus y squared. A minus is like multiplying by -1. That's like having a coefficient. So we need to factor that out of our y terms there. So that's going to be minus parentheses y squared minus 4y. We got to factor out that negative from the y's. And we move the 6 to the other term, or other side. Any hypotheses yet? Okay, complete the square with the x. We add 1. We didn't have GCF, so we can just add 1 to the other side. Complete the square with the y's. -4 divided by 2 is 2. 2 squared is 4. So we add 4 inside the parentheses, but there was a negative in front, so we got to subtract 4. So let's keep simplifying. We got x minus 1 squared minus y minus 2 squared is equal to 3. So what are we thinking now? Is it a circle? Why is it not a circle? Because of the minus. So which one's the only one with the minus? A hyperbola. It's a hyperbola. Okay, so let's finish off making it look like a hyperbola. A hyperbola is also equal to 1, so we need to go through and divide by 3. There's nothing here to simplify, so that's just x minus 1 squared over 3 minus y minus 2 squared over 3 is equal to 1. Okay, let's talk about some of its characteristics. Which axis is it going to cross? Going to cross the x-axis because the x came first. It was not being subtracted. Okay, it's going to cross the x-axis. What is its center? +1, +2. Okay, it's HK. Just like a circle, just like an ellipse, just like hyperbola, they all have a center, and it's all the number being subtracted from the x and the number being subtracted from the y. Okay, so then that means our focal axis is y equals 2 for the focal axis. Okay, so all right, C, which one is C? Right off the bat, which one's C?
Parabola.
A parabola. Hey, what's up?
Gabe, can you determine your superlative thing?
Superlative.
Your superlative thing. I don't care if you want to or not. I need it. Like you're gonna do it whether you want to or not. Do you have it with you? Give me another one. Come with your room board. Get one. You're gonna sit down and do it. What? No, I got all these people.
Thanks, Carly. All right, C. Which one is C? Did we already establish this before she walked in? Parabola. Okay, it's a parabola because only one of the terms is squared. Why am I trying to point this out to you before we even start the process? Because you can save a lot of time. I have seen questions like this. They just give you, this is not the standard form. This is standard form. Okay, not vertex form. Or no, this is not standard form. I can't remember what they call this. But anyways, they'll give you this form of an equation, and they will ask you which conic section is it. Do you really want to have to go through the process of completing the square? No, there are simple differences that you can see from the very get-go that determine which one it is. A hyperbola, you should look and see if one of the squared terms is negative. If it is, it's automatically a hyperbola. For a parabola, it's really easy to tell. If only one of the variables is squared, it's a parabola. Now, an ellipse and a circle are a little bit more difficult to tell the difference between, but kind of a dead giveaway is if the constant in front of the squared terms are the same, it's a circle. If they're different, then it's an ellipse. Okay, so we'll get to the circle example here in a second. I'm just trying to point out there are key differences that can save you a lot of time and effort by just recognizing them right off the bat. All right, let's finish out C. Let's put it in its vertex form here. Completing the square. We're going to add 4, right? Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. We don't have to multiply it by anything, so we balance our equation by adding it to the other side. Y minus 2 squared is equal to 6x plus 17. Not quite finished. We need to factor out that 6. I know it does not come out evenly. Do it anyway. What do you get? 17 over 6. So this is a parabola. Which way does it open? It's y squared. Y is squared. So this one's actually going to open to the right, okay, because there aren't any negatives. Okay, there's not a negative in front of that 6. If there was a negative in front of the 6, it would open left. Okay, but it's all positive, so it opens right. Let's see here. The vertex is at negative 17 over 6, positive 2. What is the focal width? Six. What's the focal length? 6 divided by 4. 3 over 2 is the focal length. All right, last one. Let's put this circle in standard form. Here's a little hint. All these terms are divisible by 3, so go ahead and just divide everything by 3. It is a circle. And while I'm doing that, I'm going to rearrange my terms. So minus 4x plus y squared plus 2y is equal to 5. Complete the square. Plus 4, plus 4, plus 1, plus 1. So x minus 2 squared plus y plus 1 squared is equal to 10. So my center is at 2, negative 1. My radius is the square root of 10, which doesn't reduce. That's all we can talk about with circles is where's the center, where's the radius. It doesn't get much more thrilling than that. It's just kind of, it is what it is. All right.